label your triangle according to where your reference angle is situated. Okay, you can remember that, right?
Yes.
Okay, so I'll write a couple of steps out for you here. Our first step is to label our triangle. Is label EL or LE? EL. Okay, label your triangle, and you do that by looking at our reference angle. Okay, so these are the steps we take in order to calculate an unknown side in our triangle. Now obviously we can't go and use Pythagoras. Why can we not use Pythagoras? Because Pythagoras we need at least two sides in the triangle. Here we only have one. Okay, so step one is to go and label your triangle according to a reference angle. Okay, step two, we are going to choose a ratio. Yeah, we're going to go and choose our ratio. Okay, but now you say to me, man, but what do you mean by choosing a ratio? Okay, our ratio is silly, old hens, cackle, and hop together or alone. Okay, so now we're going to pick a ratio in terms of what we have, grade 10s. Okay, so we know we've got 57 degrees, which is our reference angle. Okay, what else do we have? Our hypotenuse, which is 12. Okay, 90 degrees, that's just standard, we leave that for now. Okay, what are we trying to calculate, grade 10s? X. And x is what? The opposite side. So in this question, does the adjacent side have any relevance to my question? No, it's just there. It's not what we want to calculate. We don't have the length of the adjacent side, so it's irrelevant. Okay. Right, so which out of the three ratios includes the two sides which are most important in this question, which is opposite and hypotenuse? Which is that? Okay, so for this question, we're going to work with sin. Okay, you with me? Right. So we're going to use sin theta is equals to opposite over hypotenuse. Okay, so this that I've just written down is notation before substitution. I haven't substituted anything in yet. Okay, right, theta is your reference angle. Do I have the size of theta?
Yes.
Okay, what is it? 57. Okay, 57. So I'm going to go put 57 in at theta. I'll say I'm going to put 57 in at theta, and then I want to write theta again. Okay, so we're going to put 57 in here. Okay, 57. Okay, what is my opposite? What is the length of my opposite side? X. And what is the length of my hypotenuse? 12. Okay, now this acts as a normal linear equation now. We want to solve for x, so we want to get rid of any other number or variable that is in the way of us having x on its own. Okay, so we're back to inverse operation, multiply, you divide, add, you're going to subtract, we're back to that. Okay, so we want x alone, which is here. Okay, so x is being divided by 12. Inverse operation, we're going to multiply both sides by 12. So on the right hand side, the 12s are going to cancel. Here. Are you with me? And we then have x on its own. Okay, and in your calculator, you'll type this in exactly as is. Okay, 12 times sin 57. Did we even have to put that times there? No, because remember, if there's no operation in between, it's a times. Okay, so our final answer is going to be 10.06. It stays 06 because the third number is a 4. So if it's 4 below, it stays the same. Okay, so it's going to be 10.06. Okay, we're not going to write centimeters or anything because they haven't given us units for that one side given in the triangle. To this one, okay, so this could be question A. Question B could be go and calculate the adjacent side. Now, to calculate the adjacent side, you could use trigonometry, or now you could go use Pythagoras because we have the length of the opposite side, which is 10.06. So do you see now you have two sides given. So to go and calculate the third side, you can go use Pythagoras because now we do have two sides. Okay. Right, let's move to the next one. Okay, so first things first, you're going to go draw your sets of eyes and your reference angle, which is 35 degrees. So we're here. Okay, we're going to go and we're going to label our triangle according to our reference angle. First things first is always label your hypotenuse. Okay, because we don't want to confuse the hypotenuse and the opposite side. Okay, so opposite your 90 degrees is your hypotenuse. Opposite your 35 degrees is your opposite side. You guys okay? And directly next to is your... Okay, quickly I stand corrected. We don't want to confuse our adjacent and our hypotenuse. Okay, sorry about that. Okay, right, so I'm not going to rewrite your steps, but the first step is we're going to now label our reference angle, our triangle according to our reference angle, which we've done. We're now going to go and choose a ratio which is relevant to the triangle you're working with. Right, so we've got silly, old hens, cackle, and hop together or alone. Okay, so what is relevant in this triangle, grade 10s? It is, okay, the adjacent side and hypotenuse. Opposite is irrelevant because it's not what we want to calculate and they didn't give us the length of the opposite side. Okay, so we want to use a ratio that's got adjacent and hypotenuse, which is cos. Right, so cos theta is equals to adjacent over hypotenuse. Do we have the size of our reference angle? Yes, it's going to be cos 35 degrees. The length of our adjacent side is 7, and the length of our hypotenuse is x. Okay. Okay. So literally what you want to calculate is at the bottom. Okay. All we're going to do is we're going to do a straight switch. This x is going to move here, and this cos 35 is going to move there. That's it. Okay, so we don't change the value of anything. The only time something changes when we're swapping is with exponents. When you move it to the top or move it down to the bottom, the exponent's value changes. Okay, so this is going to be x is equals to 7 over cos 35. The only time we second function is when we're trying to work out the angle. Only time we second function. Because, look here. Into your calculator, just like it is, 7 over cos 35, and your final answer is 8.55. Okay, so x is going to be 8.55. Now we move on to calculating angles. Okay, so do you see previously an angle and the side was given? Now they give us two sides and we need to go and calculate an angle. Okay. So the only thing you need to remember when calculating an angle, this is when we're going to push shift. Okay, shift. So we can get that sin second function, cos second function, and tan second function. Okay, so they want us to go and calculate angle C. So angle C is going to be our reference angle. Are you with me? Okay. So our eyes are going to be drawn over here. Okay, so our first step is to, should we say find your reference angle? Or, because not find, because they're going to give you what angle they want. It's fine, let's label our triangle still. Okay, with our reference angle. Okay, so if you're looking at our reference angle from here, always again label your hypotenuse first. This is going to be your opposite side. And this is going to be your adjacent. Okay, our second step. Again, choose your ratio. Now again, over here, what has relevance? The hypotenuse and? Okay, so we're going to make sure we choose a ratio that has that. Okay, so we've got sin theta, silly old hens, cackle and hop, together or alone. So which side am I going to use? Okay, sin. Okay, so we don't have the reference angle, and my reference angle is what? C. Okay, so this is going to be sin C. Okay, it's not theta. They're letting you know that your reference angle is C. If they said calculate theta, beta, alpha, that's when you go put it in there. Okay? What is my opposite side? Hmm? No, you don't have to. No, you don't have to. Sin C, yeah, because that's what they want. That's our reference angle. Okay. My opposite side is 8. My hypotenuse is 12. Okay. Now, we need to calculate C. So we need to get rid of sin. And remember, in trigonometry, the only way to do that is to shift. Okay, so we're going to have C is equals to sin second function 8 over 12. Okay, you're with me? Okay, so we're going to shift sin 8 over 12. And your final answer is 41.81. Okay, so our angle C is going to be 41, comma, 81 degrees. I need you guys to quickly write today's date on top of this worksheet. We forgot. Today is the 8th. Right, today's the 8th. Okay, in the following figure, we've got triangle ABC. We've got AC perpendicular to BD. And I tell you that AB is 8 centimeters and B is 48.6. Okay, first thing I'm going to ask you is how many triangles do we have? 2. Okay. Right angle triangles, yes, we've got 2, but we've got 3 triangles. So it's 1, 2, and we've got the big one, which is 3. But remember, with trigonometry, we only, in grade 10, we only work with right angle triangles, so there's 2 right angle triangles. Okay. So they want us to calculate angle D, which is here. Okay, but now remember, in order for us to calculate an angle, what do we need? Okay, so let's go back to what we just did previously. Okay, in order for us to calculate an angle, we need at least 2 sides. Are you with me? Okay, so let's write that down. Actually, I'll be back here. Okay, in order for us to calculate an angle, we need 2 sides. Okay, so in order for us to calculate an angle, at least 2 sides are needed. Okay.